This is test video number 3, where we will examine why boulders cross-cut Stickney Crater. The contraindication for this is that we see grooves cross-cutting Stickney Crater, and that suggests that Stickney Crater predates the grooves. Our model is described in detail in test video number 1, and I suggest, if you're interested in a description of the model itself, that you view that video first. In this slide, we see a rim area, and here there are 2 grooves that pass through Stickney Crater. All right, we'll start the video, and here's a single test boulder exiting from Stickney Crater to the east. And like we saw in video 2, this boulder travels briefly along the surface and then suborbitally across the zone of avoidance, the trailing hemisphere of Phobos. It skips once and continues along the surface and drifts into space briefly on the far side of Phobos before once again engaging Phobos on the leading hemisphere. Close-up view shows the boulder rolling into Stickney Crater, rolling across the floor of Stickney Crater, and slowing as it depletes its kinetic energy and comes to a halt on the rim of Stickney Crater. The schematic view shows the path of the boulder. This boulder exited a little bit slower than the boulder shown in test video 2, but nonetheless left the surface of Phobos for perhaps half of its transit around Phobos. So its total engagement with the surface was in the vicinity of 20 to 30 kilometers, which is consistent with most grooves that we see, and perhaps half or more of its traverse around Phobos was in suborbital flight. So to review the contraindication, indeed, several grooves cross-cut Stickney Crater, suggesting that Stickney Crater predates the grooves. However, when a boulder travels more than 360 degrees around Phobos, it is possible that it could roll or slide through Stickney Crater 6 to 7 hours after the Stickney impact.